Alright, ladies and gentlemen, welcome to the video lesson for our review of right triangle trigonometry. This is the third lesson in your Algebra 2 prerequisite chapter, Chapter 0. We're going to review how to name the sides of a right triangle, then we will review SOHCAHTOA, and then finally we will look at some SAT-style SOHCAHTOA questions. And only a couple. There's actually way more of the possible problem types than we're going to have time to cover in this video. So when we're looking at a right triangle, we need to be able to name the sides of that triangle based on the acute angle that we're working with. And we only ever do trigonometry in Algebra 1 and Algebra 2, well, in Algebra 1 at least, what we're reviewing, with right triangles, and specifically we only do it with the acute angles in those right triangles. Now later on in your high school career it will be expanded out to cover more than just acute angles, but for right now what we're reviewing is what you should have learned last year in your geometry course, which is how to do right triangle trigonometry specific to acute angles. So when we're naming the sides of a right triangle, there are three names that we need to apply. One of these should be something we're very familiar with from our work with the Pythagorean theorem, that is the hypotenuse. Please note that to locate the hypotenuse in any right triangle, we first locate the right angle, and then we go across the triangle, making that side the hypotenuse. Notice it's the same thing in the other triangle. If we go across the triangle, there's your hypotenuse. You should always find the hypotenuse first, and no matter what angle you are working with, the hypotenuse is always in the same spot. Once we've named the hypotenuse, I prefer to find the opposite side next, but you could find either one of the other sides. Just have to make sure that you find them accurately, because the other two sides are named based on whichever angle you are currently working with. So you'll notice that in the picture next to the word opposite here, we are describing the leg of the triangle that is opposite of the angle. So in this case we're working with angle Q, the angle marked with the theta. If we go across the triangle, we locate the opposite side. Okay, that would be the opposite side for angle Q. If we had been working with the other angle, well, then RQ would be the opposite side, which is where this becomes complicated. Okay, but to locate the opposite side, we take the angle we're working with, we go across the triangle, and the side we find is the opposite side. The other side, the remaining side, is known as the adjacent side. Adjacent is another word for next to. If you notice, we're looking at the same picture here. When we're looking at angle Q, it is formed by the hypotenuse and one of the legs. The leg that is one of the sides of that angle is your adjacent side. It's next to the angle. Same thing over here with angle T. If we look at the sides that form it, we have the hypotenuse, which we already talked about how to find, and then the other side, which is the adjacent side. So that's a very important skill. If you cannot accurately describe opposite and adjacent every single time, you're going to have a lot of problems with right triangle trigonometry. So let's practice that skill here. We're going to go through a number of triangles, and we're going to name the sides based on one of the two angles. So no matter what angle you're working with, you always start by finding the hypotenuse. So you always find the hypotenuse first, every single time. We locate the right angle, and we go across the triangle, which makes PQ the hypotenuse. I'm going to use proper geometric notation there. Okay, then we locate the angle we're supposed to be working with. They tell us to work with angle P. So we mark angle P. I like to put a star in there so I can look at it. We go across the triangle. That is your opposite side, which would be RQ. And the other side that helps form it, PR, is your adjacent side. So on our other example here, we would start by locating the hypotenuse. That requires us to find the right angle, go across the triangle to find the hypotenuse, which is PQ. Notice it's the same triangle, so it's the same hypotenuse. The hypotenuse never, ever changes. However, if we're working with angle Q instead of angle P, well, that means PR is now the opposite side, and RQ is now my adjacent side. So notice how opposite and adjacent switched when we switched from one angle to the other. Alright, so that brings us to our next example. I'd like you to pause the video and try it on your own, then resume the video and see how you did. So here's the next triangle. Again, you'll notice that examples 3 and 4 have the same triangle picture, but they're asking you to name the triangle based on different acute angles. So either way, we start by finding the hypotenuse first. Okay, so we start off, we locate the right angle, we go across the triangle. That makes AB the hypotenuse. And it would be exactly the same thing in example 4. Locate the right triangle, go across, that's your hypotenuse. So AB is the hypotenuse of this triangle. Then we turn our attention on example 3 to the angle that we're actually working with, which is angle B. We go across the triangle to find the opposite, which would be AC. And we look next to the angle to find the adjacent, which would be BC. Okay, on the next example, we're still working with the same triangle, but instead of working with angle B, we are now working with angle A. Go across the triangle to find the opposite, would be BC. And we look next to the angle to find the adjacent, which would be AC. Again, there's one more of these. Please pause the video, try it on your own, and then resume the video to see how you did. Okay, I was wrong. There's not another one. Okay, so now that we've got that down, now that we understand that the three sides of the triangle are named opposite, hypotenuse, and adjacent based on one of the acute angles. So this is, in this picture, we're using angle A. There are three basic trigonometric ratios. They are the sine, the cosine, and the tangent. Now when I say ratio, you should hear the word fraction. Ratio and fraction are synonymous. They mean the same thing. So sine, cosine, and tangent are comparing the side lengths of the triangle, 2 out of the 3. If we're looking at the sine of an angle, so for instance, sine of angle A, that would be the ratio of the opposite to the hypotenuse, meaning we would put opposite's length on top and the hypotenuse length on the bottom and then reduce that fraction. Cosine is the ratio of the adjacent side to the hypotenuse, meaning the adjacent length would go on top, the hypotenuse length would go on the bottom. And finally, tangent is the ratio of the opposite to the adjacent, meaning opposite would go on top, adjacent would go on the bottom. Now, we taught you last year that there is a mnemonic device for helping us to remember this. And it's based on the first letters of sine, cosine, tangent, opposite, adjacent, and hypotenuse. S-O-H, so, C-A-H, ka, T-O-A, toa. SOHCAHTOA, okay? You'll notice here written two different ways, okay? We've got just written out SOHCAHTOA, and more accurately how I like to write it, which is as fractions. Sine of an angle is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, tangent of an angle is opposite over adjacent. So the next thing we need to be able to do is take a picture and write out sine, cosine, and tangent as both a fraction and as a decimal, and we need to round accurately to the nearest hundredth for that decimal. So if you have your calculators handy, again, what we're going to do here is we are going to go into the picture. We are going to start by locating the hypotenuse. So we locate the right angle, we go across the triangle, 10 is your hypotenuse. Then we mark the angle that we're working with, which by the way is right here. All three of these are asking you to find the sine, cosine, or tangent of angle A. So we're working with angle A, which means we go across the triangle. The 8 is our opposite. We go next to angle A. 6 is our adjacent. So the sine of angle A would be opposite over hypotenuse, which would be 8 over 10, which reduces to 4/5 and is equal to 0.80. Cosine is adjacent over hypotenuse, ka, C-A-H. So that would be 6 over 10, which reduces to 3/5 or 0.60. Finally, the tangent of A, according to SOHCAHTOA, is the relationship between the opposite and the adjacent. So we would say 8 over 6, which is 1.3 repeating. So to round to the nearest hundredth, we would look at the third digit, which is a 3. Since that is less than 5, we would round it down. And we would look at a value of 1.33 for our tangent. Now it is worth noting that I should have reduced this fraction to 4/3. Okay, so that should be 4/3, which is 1.33 approximately. Same thing on example 6. Locate your hypotenuse first by going across from the right angle. Then notice we are now talking about angle C in all three problems. So now we're working with angle C, which makes 8 our opposite and 15 our adjacent. Sine is opposite over hypotenuse, which is so. That would be 8 over 17, which does not reduce. So we would just take that and we would put it into our calculator to divide. 0.47, and our third digit is a 0, meaning we would round down to 0.47. Cosine is adjacent over hypotenuse. That is 15 over 17. That also does not reduce, so we would turn that into a decimal, 0.88. The third digit is a 2. So again, it's less than 5. We would round it down. Finally, tangent is opposite over adjacent, which would be 8 over 15. That also does not reduce, so that's your fraction. 8 divided by 15 is 0.53 repeating, meaning the third digit is a 3, and we would round that down to 0.53. There is one more of these. Please pause the video and try it on your own. Then resume the video and see how you did. So in the third and final example, you should have marked 13 as being your hypotenuse. Since we are working with angle F in the problem, that means that the 5 is your opposite and the 12 is your adjacent. Okay? Again, it's all about being able to name things correctly. Remember that we are working SOHCAHTOA. On your notes, you should not need to rewrite this because it should still be at the top of the page. So sine is opposite over hypotenuse, which is 5 over 13. That does not reduce, so all we need to do is convert that into a decimal, which is 0.384, which would round down to 0.38. Cosine is adjacent over hypotenuse, which would be 12 over 13. Again, that does not reduce, so that's your fraction. 0.92, and that last digit is a 3, meaning 0.92 is what we're looking for. And tangent is opposite over adjacent, which is 5 over 12. That does not reduce. 5 divided by 12 is 0.41, and that third digit is a 6. This is the first time we've had it round up. 6 is bigger than 5, so we would change the 1 to a 2. Okay, our last two examples in the notes are SAT-style questions. They are not very tricky if you are very good at naming the sides of the right triangle. So starting in example 8, it says, in the right triangle shown below, the sine of the angle marked X is 3 over 5. Remember that sine is opposite over hypotenuse. So what that allows us to do is write in side lengths for angle X on the opposite side, which is 3, and the hypotenuse, which is 5. Now we could use the Pythagorean theorem if needed to find the other side of the triangle, but we don't need to in this case because of what we are asked. So we are asked to locate the cosine. I'm changing colors because we're looking at the other angle. The cosine of angle Y. Well, cosine is adjacent over hypotenuse. Now the hypotenuse has not changed. That is still 5. But for this angle, for angle Y, the 3 is no longer the opposite side. That is the adjacent side, which means the cosine of angle Y is also 3/5. That's a very common SAT motif because they want to see how well you understand the naming process. Example 9 is only difficult because they did not give us a picture. In a right triangle, the tangent of one of those angles, let's say it's this one, okay, the tangent of that angle is 24 over 7. So we'll put a right angle here. That is opposite over adjacent. So just like we did before, the opposite will be 24. The adjacent will be 7. Okay? Then it asks us to find what is the tangent of the other acute angle. So we'll look at this one. Okay? Well, the tangent of that angle is still opposite over adjacent, but opposite and adjacent have switched because we have switched from looking at the angle marked with black to the angle marked with red, which means that instead of 24 over 7, our answer will be 7 over 24. These are just 2 examples of the SAT style questions you could see over sine, cosine, and tangent. Please, 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 please look up resources. Okay, Google search basic triangle trigonometry SAT, do some problems, read some examples, read some explanations, and make sure you're ready for the SAT this spring. Thank you very much for your time and attention. Hopefully you are now capable of completing your classwork assignment.